This emphasis on crew protection represented a profound paradigm shift in tank design, moving away from the historical notion of tanks as potentially expendable platforms and towards a vision of them as highly survivable, sophisticated weapon systems where the lives of the four-person crew were paramount. This inherent trust, this unspoken promise of safety, would become a cornerstone of the crew's courage and operational effectiveness. The final product, christened the M1 Abrams in honor of General Crichton Abrams, a legendary armored commander of World War II and the Vietnam War, and later the Army Chief of Staff, was unveiled in 1979. It was a culmination of years of intense research, development, and rigorous testing, a truly groundbreaking machine that would redefine the meaning and capabilities of a main battle tank. The initial public and military reaction was one of awe and anticipation. Here was a machine that looked like nothing that came before it, promising to deliver a decisive edge in any future conflict. Its legend would grow exponentially with every engagement, every training exercise, and every technological refinement, solidifying its place not just in military history, but in the popular imagination as the embodiment of American armored might. At the literal heart of this steel behemoth lies perhaps its most distinctive and revolutionary component, the Honeywell AGT 1500 gas turbine engine. While most main battle tanks of the era, both Western and Eastern, relied on robust, multi-cylinder and proven diesel engines, the M1 Abrams took a radical and highly controversial departure. The decision to employ a turbine engine was met with considerable skepticism and presented formidable engineering and logistical challenges, yet it ultimately delivered an unparalleled blend of raw power, exceptional performance, and critical operational advantages that few, if any, diesel counterparts could match. Imagine the raw, untamed power of a jet engine, scaled down and meticulously adapted for terrestrial combat, delivering a staggering 1,500 shaft horsepower. This colossal output allowed the Abrams to accelerate with astonishing swiftness for a vehicle weighing over 60 tons, granting it a mobility advantage that frequently baffled and frustrated adversaries on the battlefield. It could achieve road speeds exceeding 40 miles per hour and maintain impressive off-road speeds, enabling rapid tactical maneuvers, sweeping flanking actions, and lightning-quick repositioning, all critical elements in the fluid, fast-paced battlefields of modern warfare. The turbine engine offered several key distinct advantages over traditional diesels. Firstly, its power-to-weight ratio was simply exceptional, directly translating into superior acceleration and unparalleled agility. This responsiveness allowed the Abrams to rapidly cross open ground, exploit gaps in enemy lines, or quickly egress from dangerous situations. Secondly, the AGT 1500 was a multi-fuel engine, meaning it possessed the unique capability to operate on a wide range of fuels, including military standard JP8 jet fuel, diesel, marine diesel, and even gasoline in an emergency. This logistical flexibility was a significant asset, particularly in extended operational deployments or in environments where specific fuel types might be scarce or difficult to procure. Thirdly, and surprisingly, the turbine engine operated with a remarkably quiet hum at lower speeds, a distinct advantage in stealth and tactical approaches, especially under the cover of darkness. The characteristic high-pitched turbine whine often associated with it only became prominently noticeable at higher RPMs when the tank was moving at speed. Furthermore, the turbine engine was known for its quick and reliable starting in frigid cold weather and its impressive overall reliability, requiring less routine maintenance compared to the often complex, multi-cylinder diesel engines of its time. The engine was often designed as a removable power pack, allowing for quicker field replacement. For the crew nestled within the M1 Abrams, this powerful engine meant not just raw responsive power, but also a remarkably smoother ride, significantly less vibration compared to diesels, and a certain psychological edge knowing their vehicle possessed such a potent and responsive power plant. This continuous, dynamic evolution of protection underscores a fundamental truth of warfare. It is a constant, relentless arms race, and the Abrams has consistently remained at the forefront, adapting, evolving, and ensuring its crews have the best possible chance of returning home safely, embodying a commitment to crew protection above all else. The third, equally critical pillar of the M1 Abrams design philosophy, alongside its extraordinary mobility and unparalleled survivability, is its overwhelming firepower. A tank, no matter how fast or how well protected, is ultimately judged by its intrinsic ability to effectively engage, neutralize, and destroy enemy threats. The Abrams was designed from the outset to be a devastating force on the battlefield, capable of delivering precise, lethal blows at extended ranges, day or night, and in all conceivable weather conditions. This inherent capability evolved significantly during its long operational lifespan, directly reflecting both changes in threat assessment and rapid advancements in weapons technology. Initially, upon its introduction in 1980, the M1 Abrams was armed with the M68A1 105mm rifled gun. This was a proven and highly reliable weapon, derived from the highly successful British L7 gun, which had equipped many Western tanks. This 105mm gun was capable of firing a versatile variety of ammunition types, including armor-piercing fin-stabilized discarding sabot, APFSDS rounds like the M774 and M833, specifically designed for engaging and defeating other tanks, and high-explosive anti-tank rounds such as the M456, used for general anti-armor duties and against fortifications. The 105mm gun was formidable for its time, providing a significant upgrade over previous generations. However, as the Cold War progressed and intelligence indicated the rapid development of increasingly heavily armored Soviet tanks, notably the T-80, which incorporated advanced composite armor, it became abundantly clear that a more powerful main gun with greater penetrative capabilities would be absolutely necessary to maintain a decisive advantage on the future battlefield. The U.S. Army, recognizing this rapidly growing threat and the strategic imperative to retain overmatch capability, made the critical decision to upgrade the Abrams primary armament. This strategic decision led directly to the introduction of the M256 120mm smoothbore gun, a license-produced and refined variant of the highly successful German Rheinmetall RH-120. This weapon, first integrated into the M1A1 variant of the Abrams, represented a truly quantum leap in firepower, fundamentally altering the tank's combat capabilities. The crucial switch from a rifled to a smoothbore barrel was pivotal. It allowed for the firing of more advanced, longer, and significantly heavier APFSDS rounds, which rely on fin stabilization for accuracy rather than the barrel rifling that imparts spin. These kinetic energy penetrators, often affectionately referred to by crews as silver bullets due to their distinctive depleted uranium core, possess incredible muzzle velocity and unparalleled penetrative power. The evolution of these rounds is noteworthy. The M829, the original DU penetrator, M829A, the silver bullet of Desert Storm fame, capable of penetrating any known Soviet armor, M829A2, M829A3, and the latest M829A4, each with increasing length, density, and sophisticated fin designs, are capable of defeating virtually any known tank armor at combat ranges, often exceeding 3,000 meters. The 120mm gun also fired more potent heat rounds, M830/A1, and later multi-purpose anti-tank rounds, M908, offering greater versatility against different types of targets, including dismounted infantry, light vehicles, and even low-flying helicopters. For the gunner, the sheer destructive potential and precision of the 120mm M256 was a source of immense confidence. The knowledge that they could deliver a devastating blow to an adversary, often before the enemy even registered their presence, was a powerful psychological advantage, enabling them to execute their duties with cold precision even in the most intense combat situations. The satisfying thud of the breech closing, followed by the deafening roar and the heavy recoil of the main gun, and the subsequent explosion on target, were moments of intense, albeit brief, gratification amidst the fear and adrenaline of battle. However, a powerful gun, no matter how destructive, is only as effective as its ability to accurately hit the target. This is precisely where the M1 Abrams Sophisticated Fire Control System, FCS, truly comes into its own, transforming the raw power into surgical precision. Often described as the brains of the tank's offensive capabilities, the FCS integrates multiple advanced sensors, high-speed computers, and intricate optical systems to ensure an exceptionally high first-round hit probability, even while the tank is moving at speed over rough terrain. This shoot-on-the-move capability is a hallmark of modern tank design and a significant tactical advantage. Key components of this intricate system include digital ballistic computer. This high-speed, ruggedized processor is the computational core, taking inputs from various sensors and rapidly calculating the precise aiming solution required to hit a moving target from a moving platform. It accounts for range, target speed, target direction, tank cant, tilt, crosswind, air temperature, air pressure, and even the specific ammunition type selected. Laser rangefinder. An integral ND-YAG neodymium-doped yttrium aluminum garnet laser accurately and instantaneously measures the distance to the target, a crucial input for precise ballistic calculations. This allows for instantaneous and highly accurate range data, far superior to manual estimation. Stabilized sights. Both the gunner's primary sight, GPS, and the commander's independent thermal viewer, CITV, are gyroscopically stabilized in 2 axes, allowing the crew to maintain their aim on target regardless of the tank's movement. This complex system counteracts the pitch, roll, and yaw of the tank, ensuring a steady aim. Thermal optics, FLIR. A game-changer in tank warfare, the forward-looking infrared, FLIR, thermal imagers allow the crew to see in complete darkness, through smoke, fog, rain, and even light foliage, by detecting subtle heat signatures. This gave Abrams crews an unparalleled first sight, first shot advantage, particularly at night, often allowing them to engage and destroy enemy tanks before they even knew they were being targeted. Crosswind sensor and cant sensor. These highly sensitive sensors provide continuous, real-time data on environmental factors, wind speed and direction, and the tank's precise angle of inclination, further refining ballistic calculations for extreme accuracy at extended ranges. Muzzle Reference System, MRS. A sophisticated system that continuously monitors and compensates for any sag or thermal distortion of the gun barrel, ensuring that the gun's line of sight remains perfectly aligned with the sight. Ammunition Type Selector. A user-friendly interface that allows the gunner to quickly select the appropriate round for the target at hand, whether it's an AP FSDS for heavy armor, a heat round for lighter vehicles, or a multi-purpose round for fortifications or dismounted infantry. The seamless integration of these advanced systems creates the fearsome hunter-killer capability. The commander, using the Independent Thermal Viewer, CITV, can continuously scan for new targets, maintaining unparalleled situational awareness, while the gunner is simultaneously engaging an existing target. Once a new threat is identified and designated, the commander can slave the main gun to the new target, allowing the gunner to immediately acquire, take over, and engage, significantly reducing engagement time and dramatically increasing tactical flexibility and combat tempo. This level of automation and precision means that the Abrams gunner doesn't just aim and shoot. They manage a complex, highly advanced weapon system designed for unparalleled accuracy and devastating lethality. The sheer technological superiority of this fire control system grants the Abrams crew a decisive, often overwhelming edge, turning potential threats into defeated adversaries with swift surgical strikes. It minimizes the variables, giving the crew maximum confidence in their ability to perform their mission with devastating effectiveness. Complementing the destructive power of the main gun are the Abrams' secondary armaments, providing critical versatility and close-quarter defense. A 7.6
62mm M240 coaxial machine gun is mounted precisely parallel to the main gun, allowing the gunner to engage infantry, light vehicles, or suppress targets without expending precious 120mm rounds, conserving primary ammunition for harder targets. The tank commander typically has access to 1.50 caliber M2 heavy machine gun mounted on the turret, providing a potent anti-personnel and anti-light vehicle capability, particularly crucial in urban environments. In later variants, with the Tank Urban Survival Kit Tusk package, this became the common remotely operated weapon station, Kraus 2, allowing the commander to operate the 1.50 caliber from within the protected confines of the turret, enhancing crew safety. The loader also has a 7.62mm M240 machine gun, often pinto-mounted near the hatch for close-in defense and situational awareness. These secondary weapons provide essential close-quarter defense, suppressive fire, and anti-aircraft capabilities against low-flying threats, making the Abrams a truly versatile combat platform capable of addressing a wide spectrum of threats across various combat scenarios, from open desert to dense urban environments. Beyond sheer destructive power, the Abrams firepower ethos extends to its operational speed and efficiency. The ability to load and fire rapidly thanks to the skilled loader, the lightning fast speed with which the fire control system acquires and tracks targets, and the devastating lethality of its advanced ammunition combine to create a tank that isn't just powerful but efficiently powerful. This efficiency translates directly into a profound tactical advantage on the battlefield, enabling Abrams crews to dominate engagements, suppress enemy advances, and secure objectives with a decisive force that reshapes the combat environment. The Abrams truly represents a complete package, a machine meticulously designed to survive, move, and destroy with unparalleled effectiveness, a testament to decades of engineering refinement. The M1 Abrams' renowned mobility is not solely attributed to its powerful AGT-1050 turbine engine. It is a holistic engineering achievement, integrating a sophisticated suspension system, durable tracks, and an exceptionally robust power transmission to create a vehicle that can traverse diverse and challenging terrain with remarkable speed and agility. This inherent ability to move rapidly, reposition dynamically, and exploit terrain features is a critical component of modern armored warfare, allowing for decisive flanking maneuvers, rapid exploitation of breakthroughs, and swift disengagement when necessary. The Abrams is not merely fast on a paved road, it is meticulously designed to maintain high operational speeds and combat effectiveness across rugged, unforgiving cross-country environments, a true testament to its engineering brilliance and the tactical doctrine it enables. At the heart of its exceptional cross-country performance is its robust torsion bar suspension system. Each of the 7 road wheels on each side is independently sprung by a torsion bar, a long, high-strength metal rod that twists to absorb impacts. This ingenious design allows for significant vertical wheel travel, enabling the tank to flex and articulate over uneven ground, minimizing jaws and maintaining consistent contact with the terrain. This independent action means that an obstacle affecting one wheel does not unduly disturb the others. Complementing the torsion bars are powerful rotary shock absorbers, which meticulously dampen oscillations and prevent excessive bouncing, ensuring a remarkably smooth ride for the crew. Crucially, this smooth ride helps maintain the stability required for the fire control system to function effectively and for the gun to remain precisely on target, even while on the move over rough terrain. The ability to shoot accurately while traversing rough terrain is a defining, game-changing feature of the Abrams, and its sophisticated suspension system plays a pivotal unsung role in making this possible. For the driver, this translates into a demanding but incredibly rewarding experience. Maneuvering such a heavy, powerful machine at speed over obstacles, anticipating terrain changes, and reacting to tactical commands requires immense skill, spatial awareness, and a keen, almost intuitive understanding of the tank's capabilities and limitations, pushing the limits of both man and machine.
The track system of the Abrams is equally vital to its mobility. It utilizes a continuous track composed of individual, high-strength steel track pads, meticulously connected by robust pins. These wide tracks are specifically designed to distribute the tank's massive weight, over 60 tons, over a large surface area, significantly reducing ground pressure. This low ground pressure allows the Abrams to traverse soft ground, deep mud, loose sand, and even light snow that would quickly immobilize heavier-wheeled vehicles or tanks with narrower tracks. The specific design of the track shoes, often featuring chevron patterns, provides excellent grip and traction on varied surfaces, enhancing its off-road agility. While incredibly durable and engineered for combat, tracks are also a primary maintenance item, susceptible to wear, damage from obstacles, or direct hits from enemy fire. Track throwing, where the track separates from the road wheels and idlers, is a serious battlefield casualty, requiring specialized recovery and often lengthy, arduous field repair. Yet, the overall design ensures maximum traction, durability, and reliability under the most strenuous and unforgiving combat conditions. The seamless combination of the powerful AGT 1500 turbine engine, the advanced Allison DDA X1100 3B hydrokinetic automatic transmission with 4 forward and 2 reverse gears, the robust torsion bar suspension, and the efficient track system grants the Abrams exceptional off-road performance. It can accelerate rapidly from a standstill, climb steep grades, often exceeding 60%, and ford shallow water obstacles up to 4 feet without preparation. Its impressive reverse speed, often matching its forward speed for short bursts, is also a significant tactical advantage, allowing for quick evasive maneuvers or rapid repositioning under intense enemy fire. In combat, this translates directly into unparalleled strategic and tactical flexibility. An Abrams unit can quickly redeploy to counter an enemy breakthrough, bypass entrenched positions, or exploit weaknesses in an enemy's defensive line with astonishing swiftness. This operational agility keeps adversaries constantly off balance, forcing them to react to the Abrams initiative rather than dictating the pace and direction of the battle. The sheer speed and brute force with which the Abrams can surge across a battlefield, its massive bulk seemingly defying gravity and inertia, can be an overwhelming sight, instilling fear in the enemy and profound confidence in the crews who command it. It dictates the rhythm of engagement. However, the immense size and prodigious weight of the M1 Abrams also present considerable challenges for strategic mobility, the ability to move the tank across continents or vast distances. At over 60 tons, and even heavier for later variants with additional armor, sometimes exceeding 70 tons, it is a colossal machine. Transporting an Abrams over long distances requires heavy-duty flatbed trucks known as heavy equipment transporters, HETs, specialized military rail cars, or very large military transport aircraft like the C-7 Globemaster III or the even larger C-5 Galaxy. While a single C-7 can carry 1 Abrams and a C-5 can carry 2, air transport is an incredibly resource-intensive and often costly endeavor, not always feasible for moving an entire armored brigade or division. This logistical consideration heavily dictates the deployment strategies for Abrams units, often requiring pre-positioning equipment in strategic locations or extensive planning for overland and sea lift operations, which can take weeks. Once deployed to a theater of operations, the focus shifts to operational mobility and the intricate, constant logistics of fuel and resupply, a perpetual, demanding dance to keep these hungry, powerful giants moving, fighting, and dominating the battlefield. The roar of its engine, the rhythmic grinding of its tracks, are not just sounds of power. They are the rhythmic heartbeat of a complex system that demands constant, dedicated support to unleash its full, terrifying potential. Ultimately, a tank, no matter how technologically advanced, is only as effective as the crew that operates it. The M1 Abrams, for all its unparalleled technological sophistication and engineering marvels, is fundamentally a weapon system designed to be wielded by highly trained, cohesive, and courageous human teams. The four-person crew, commander, gunner, loader, and driver, are the literal heart and soul of the tank, each role demanding specialized skills, unwavering discipline, and an unbreakable bond forged in the crucible of intensive training and the searing heat of combat. Their collective expertise, their ability to make split-second decisions under unimaginable pressure, and their capacity to act as a single, synchronized unit transform the formidable steel beast into a living, breathing, and devastating instrument of war. The Tank Commander, TC, is the undisputed leader, the tactical brain of the vehicle. Sitting in the turret, often with a clear panoramic view of the battlefield through the commander's hatch or through the sophisticated independent thermal viewer, CITV, the TC is responsible for maintaining ultimate situational awareness, identifying and prioritizing targets, communicating seamlessly with other units in the platoon and company, and, most critically, making decisive tactical decisions that can determine the fate of the tank and its crew. They direct the driver, assign targets to the gunner, and oversee the overall functioning and integrity of the tank. Their role is one of immense, often solitary responsibility, requiring strategic thinking, decisive action, and the ability to maintain unwavering calm amidst overwhelming chaos. The immense weight of the lives of their crew and the ultimate success of their mission rests heavily on their shoulders. They are the eyes, the ears, and the commanding voice of the Abrams in combat, a direct, vital link between the raw power of the tank and the broader, often confusing, battlefield picture. This mental fortitude is learned, earned, and honed through years of training and experience. The gunner is the precision strike expert, the executioner of the commander's will, responsible for operating the devastating 120mm main gun and the coaxial machine gun. Huddled in the turret, their eyes meticulously glued to the primary sight, the gunner painstakingly tracks targets, operates the laser rangefinder with practiced ease, and, upon the commander's decisive command, fires the devastating 120mm round with surgical accuracy. Their training is exhaustive and relentless, encompassing everything from advanced ballistics and trajectory compensation to intricate fire control system operations and rapid target acquisition techniques. In the overwhelming heat of battle, the gunner's focus must be absolute, their movements fluid, precise, and practiced, ensuring that every single shot counts, that every round finds its mark. The immense pressure of being the primary agent of destruction, knowing that a single error could mean mission failure, lost lives, or even disaster, demands nerves of steel, unparalleled proficiency, and an almost zen-like concentration. The deeply satisfying thud and recoil of the main gun and the subsequent, often thunderous explosion on target are fleeting moments of intense gratification and validation amidst the pervasive fear and adrenaline. The loader is the tireless workhorse of the turret, a role demanding immense physical strength and unwavering stamina. They are directly responsible for manually loading the heavy 120mm rounds into the breech of the main gun. This is an incredibly physically demanding role, especially in a dynamic and violent combat environment where speed and a high rate of fire are absolutely critical. A skilled and conditioned loader can cycle rounds remarkably fast, often under immense G-forces as the tank maneuvers aggressively. Beyond their primary loading duty, the loader also assists the commander with maintaining situational awareness, operates the loader's pintle-mounted machine gun for close-in defense, and performs critical preventative maintenance tasks on various internal systems. Their physical strength, agility, and sheer stamina are crucial to maintaining the tank's devastating rate of fire, ensuring there are no lulls in the offensive. They are the unsung heroes of the crew, their tireless, often brutal efforts directly enabling the tank's sustained offensive power. The rhythmic clang of a fresh, heavy round being slammed into the breech is a visceral sound of impending destruction, a testament to the loader's vital and exhausting contribution.
Finally, the driver occupies the confined hull of the tank, operating the tank's intricate controls and skillfully navigating the often treacherous battlefield. Their skill in maneuvering the 60-ton beast over rough terrain through complex urban environments and at high speeds is absolutely paramount. They must anticipate terrain features, react instantly and intuitively to commands from the commander, and ensure the tank is always in the optimal position for both offensive engagement and maximum defensive protection. The driver's compartment is an incredibly confined, often claustrophobic space, offering a severely limited field of view through periscopes, requiring them to rely heavily on the commander's precise directions and, in later variants, a thermal viewer. The physical demands of driving an Abrams for extended periods, coupled with the profound mental stress of navigating a hostile, ever-changing environment, require immense concentration, unwavering endurance, and a deep understanding of the tank's kinetic capabilities.
The omnipresent roar of the turbine engine, the relentless rumble and vibration of the tracks, and the constant jarring movement are their immediate, all-consuming world. The training regimen for an Abrams crew is incredibly rigorous, unforgiving, and meticulously designed, emphasizing not only individual proficiency in each role, but, far more importantly, seamless, almost telepathic teamwork. Crews spend countless grueling hours in advanced simulators, honing their skills in hyper-realistic combat scenarios, learning to communicate effectively under duress, and reacting instinctively to unexpected threats. This initial phase is followed by extensive live-fire exercises, where they apply their honed skills with real ammunition and against real targets, experiencing the full, thunderous power and heavy recoil of the main gun, learning to manage the incredible forces at play. This intensive, shared training builds an incredible level of trust, mutual respect, and profound camaraderie among the crew members. In the confined, high-stress, often life-or-death environment of an Abrams in combat, each crew member relies implicitly, utterly on the others. Their very lives are literally in each other's hands. This unbreakable bond, forged in sweat, adrenaline, and shared danger, is what truly transforms the M1 Abrams from an impressive collection of steel and electronics into a formidable, living, breathing fighting force. The tank is indeed a marvel of engineering, but the crew, with their intricate emotions, their profound fears, their unwavering courage, and their collective expertise, are its very soul, transforming cold steel into a devastatingly effective, yet distinctly human weapon. Supporting these advanced machines and their courageous crews is an equally complex and absolutely vital network of logistics and maintenance. The M1 Abrams, for all its ruggedness and advanced engineering, is a highly sophisticated weapon system that demands continuous, meticulous care and a robust, resilient supply chain to remain operational and combat effective. This intricate tale of support is as crucial to its effectiveness as the tooth of its powerful gun and impenetrable armor. Without efficient, well-executed logistics, even the most powerful and advanced tank becomes nothing more than an inert monument to misplaced priorities. This is where the unsung heroes, the dedicated maintainers, the skilled mechanics, and the meticulous logisticians come into play, working tirelessly, often under arduous and dangerous conditions, behind the front lines to keep the Abrams in the fight, moving, shooting, and surviving. The most prominent and often challenging logistical hurdle associated with the Abrams is its truly prodigious fuel consumption, primarily due to its high-performance AGT 1500 gas turbine engine. As previously noted, this engine is exceptionally powerful, but also exceptionally thirsty, particularly at idle or during sustained high-speed maneuvers. This inherent characteristic necessitates a constant, uninterrupted flow of fuel, typically military standard JP-8 jet fuel. To support sustained combat operations, military planners must establish elaborate and highly efficient fuel distribution networks, often involving forward arming and refueling points located strategically close to the battlefield. These FARPs are critical nodes, allowing tanks to quickly refuel and rearm before returning to the fight, minimizing precious downtime and maximizing combat duration. Managing these fuel convoys, protecting them from enemy attack, and ensuring their timely delivery to the front lines is a monumental and often dangerous task, frequently operating under immense pressure and severe logistical constraints, sometimes involving multi-day drives through hostile territory. Beyond fuel, the Abrams requires a constant, steady supply of heavy 120mm ammunition, an array of specialized spare parts, and various lubricants and fluids. The 120mm rounds, particularly the dense depleted uranium kinetic energy penetrators, are incredibly heavy, bulky, and expensive. An Abrams typically carries around 40 to 42 rounds of main gun ammunition, and in a prolonged, intense engagement, these can be expended remarkably rapidly. Replenishment requires coordinated efforts, often involving specialized ammunition carriers that transport rounds from secure depots to the front lines, a process that must be fast and secure. Similarly, mechanical components, ranging from robust road wheels and durable track pads to complex engine submodules, intricate optical systems, and sensitive electronic modules, must be readily available throughout the theater of operations. The parts flow must be meticulously managed, predicting wear and tear, and ensuring that common failure points or critical components have sufficient spares in theater. This is a perpetual, complex balancing act between efficiency, cost-effectiveness, and combat readiness, often demanding innovative, on-the-fly solutions in dynamic combat zones. Maintenance itself is a demanding, multifaceted, and highly technical operation. While the AGT 1500 turbine engine is renowned for its reliability and generally boasts longer service intervals compared to some complex diesels, it still requires specialized diagnostic tools and highly trained technicians for complex repairs. The sophisticated fire control system system, the intricate armor arrays, and the sensitive electrical and electronic systems all demand expert attention and specialized diagnostic equipment. Maintenance can range from routine checks, fluid top-offs, and minor repairs conducted by the tank crew itself, often referred to as Level 1 maintenance, to major component replacements and extensive overhauls performed by dedicated, highly skilled maintenance units, Level 2 and 3 maintenance, often involving battalion or brigade support. In the heat of the field, damaged or immobilized tanks often need to be recovered, sometimes under intense enemy fire, and transported to designated maintenance points for repair. This recovery process is itself a dangerous and highly complex operation, requiring specialized heavy recovery vehicles like the M88 Hercules armored recovery vehicle, often necessitating specialized training, immense physical strength, and profound courage from their crews. The mechanics, maintainers, and logisticians, often working around the clock in incredibly challenging conditions, battling dust, searing heat, freezing cold, or driving rain, are the true unsung heroes of armored warfare. They brave the elements, the exhaustion, and the ever-present threat to keep the tanks rolling, often sacrificing their own comfort and safety. Their intimate knowledge of the Abrams' complex inner workings, their ingenious problem-solving skills under pressure, and their sheer grit are absolutely indispensable to the fighting force. For them, a broken tank isn't just a machine, it represents a potential lifeline for a crew, a critical asset for the mission, and a symbol of national power. Their profound pride comes from seeing a once crippled Abrams rumble back into action, knowing their hands, their minds, and their tireless efforts made it possible. This dedicated, often overlooked support network ensures that the Abrams, a marvel of engineering, remains a formidable, reliable, and continuously available force on the battlefield, proving unequivocally that its prowess is as much about groundbreaking innovation as it is about unwavering reliability, meticulous maintenance, and relentless logistical support, a true symphony of military infrastructure. The story of the M1 Abrams is not static. It is a dynamic, evolving narrative of continuous improvement, a relentless pursuit of perfection driven by invaluable lessons learned in the unforgiving crucible of combat and the ever-changing, unpredictable nature of the threats it faces. Since its initial introduction, the Abrams has undergone a series of significant, transformative upgrades, giving rise to distinct variants, each meticulously building upon the strengths of its predecessor and incorporating cutting-edge technologies. This iterative design process, a continuous dialogue between combat experience and engineering innovation, ensures that the M1 Abrams consistently remains at the absolute forefront of armored warfare, continuously setting and raising the gold standard it has become universally known for. The initial production variant, simply designated the M1 Abrams, entered service in 1980. It featured the then powerful 105mm rifled gun, sophisticated first-generation composite armor, and the revolutionary AGT 1500 turbine engine. It represented a monumental leap over the venerable M60 Patton and quickly became the cornerstone of U.S. Army armored divisions, its deployment signaling a new era. Its early deployments focused intensively on crew familiarization and rigorous training, preparing for the looming existential threat of a massive armored confrontation with the Warsaw Pact in Central Europe. The first major and highly significant evolution came with the M1A1 Abrams, which began production in 1985. The most impactful upgrade was the adoption of the formidable 120mm M256 smoothbore gun, granting the tank vastly increased firepower and penetrative capability, specifically designed to counter the latest and most heavily armored Soviet tanks. It also incorporated improved second-generation depleted uranium DU composite armor, significantly enhancing its protection against the most advanced kinetic energy penetrators. Other crucial enhancements included a redesigned and more effective nuclear, biological, and chemical NBC protection system for the crew, providing a sealed, filtered environment, and an automatic fire suppression system, AFSS, for increased internal safety. The M1A1 was the variant that famously dominated during Operation Desert Storm in 1991, proving its unparalleled mettle in large-scale conventional warfare. Building directly on the phenomenal success of the M1A1, the M1A2 Abrams introduced a wave of digital and situational awareness enhancements, truly transforming the tank into a networked combat platform, entering service in 1992. While externally quite similar to the M1A1, the M1A2 featured a completely redesigned commander station with an independent thermal viewer, CITV, granting true, game-changing hunter-killer capability, allowing the commander to scan for targets independently of the gunner. The most pivotal internal upgrade period was the introduction of the Intervehicular Information System and later the Force X-1 Battle Command Brigade and below FBCB-2 system, which provided digital battlefield mapping, precise blue force tracking, identifying friendly units in real time, and significantly enhanced digital communication capabilities. This effectively transformed the M1A2 from a powerful but analog tank into a truly digital fighting machine, seamlessly integrated into a networked battlefield. The crew's ability to share and receive real-time tactical information drastically improved situational awareness, drastically reducing friendly fire incidents and enhancing coordinated operations across the entire unit. The driver also received a dedicated thermal viewer, significantly improving night driving capabilities and overall safety. The M1A2 system enhancement package marked further continuous advancements, primarily focusing on computational power, network integration, and modularity to handle future upgrades. 1. M1A2 SEP-V1, also widely known simply as M1A2. Introduced in the early 2000s, this upgrade focused on a massive increase in computational power, the integration of vibrant color flat panel displays for enhanced crew interface, and significantly improved thermal sights for both the commander and gunner. It also integrated new high-capacity cooling systems to support the increased thermal load from the expanded electronics.
This variant was the workhorse during the initial phases of Operation Iraqi Freedom, where its advanced digital capabilities proved invaluable in navigating complex and dangerous urban environments. M1A2 SEP-V2. Entering service in the late 2000s, the V2 brought even more robust computing systems, higher resolution displays, and critically improved communications equipment, including the ability to interface with Joint Battle Command Platform, JBCP. Crucially, it included the Common Remotely Operated Weapon Station, CROWS-2, allowing the commander to operate the 50-caliber machine gun from inside the protected confines of the turret, dramatically enhancing crew safety, particularly in urban combat scenarios where exposed commanders were highly vulnerable. Further armor upgrades, particularly to counter the growing threat of improvised explosive devices, IEDs, and rocket-propelled grenades, were also integrated, often under the broader Tank Urban Survival Kit (TUSK) moniker. M1A2 SEP-V3, often referred to as M1A2C. The most recent and currently most advanced operational variant, introduced in the mid-2010s, focuses intensively on power generation, network capabilities, and enhanced lethality. It features upgraded armor materials for even greater protection, improved power generation and distribution systems to support future advanced electronics, and cutting-edge communication systems for seamless integration into future networked battlefields. The V3 also introduced new ammunition types, including the Advanced Multi-Purpose Round, AMP round, M1147, which cleverly combines the capabilities of several older rounds, heat, MP-AT, obstruction reduction, into one, significantly simplifying logistics and increasing tactical flexibility on the battlefield. Beyond these core combat variants, specialized versions of the Abrams have also been meticulously developed, showcasing the incredible robustness and versatility of the platform. The M104 Wolverine Heavy Assault Bridge utilizes the Abrams chassis to carry and rapidly deploy a modular bridge, enabling quick river crossings or gap spanning, a critical capability for maintaining momentum. The M1150 Assault Breacher Vehicle, ABV, also built on the Abrams chassis, is a fearsome machine specifically designed to clear treacherous minefields and complex obstacles, featuring a full-width mine plow, a formidable line charge system, MICLIC, to clear lanes, and a commander's weapon station. These specialized vehicles underscore the foundational robustness and inherent versatility of the Abrams platform, adaptable to an impressively diverse range of critical mission requirements beyond direct combat. The continuous, relentless evolution of the M1 Abrams throughout its long service life unequivocally demonstrates an unwavering commitment to maintaining its decisive edge in a constantly changing and increasingly complex global security landscape. Each variant meticulously reflects a specific, informed response to emerging threats and technological opportunities. The dedicated designers and engineers, in constant and direct dialogue with combat veterans and frontline troops, have meticulously refined every single aspect of the tank, from its internal digital architecture and power management systems to its external armor profile and weapon systems. This relentless dedication ensures that the M1 Abrams, a machine born in the Cold War, not only remains but continues to strengthen its position as a relevant, dominant, and universally feared force on the modern battlefield, a powerful testament to its enduring design, its inherent adaptability, and the unwavering human ingenuity that powers its continuous improvement.
The true ultimate measure of any weapon system lies not just in its impressive specifications, its innovative design, or its theoretical capabilities, but in its unwavering performance in the unforgiving crucible of combat. For the M1 Abrams, this baptism of fire, this ultimate proving ground, came primarily in the scorching desert sands of the Middle East, where it unequivocally proved its revolutionary capabilities, solidified its legendary status, and indelibly etched its absolute dominance into the annals of armored warfare. Each variant meticulously reflects a specific, informed response to emerging threats and technological opportunities. The dedicated designers and engineers, in constant and direct dialogue with combat veterans and frontline troops, have meticulously refined every single aspect of the tank, from its internal digital architecture and power management systems to its external armor profile and weapon systems. This relentless dedication ensures that the M1 Abrams, a machine born in the Cold War, not only remains but continues to strengthen its position as a relevant, dominant, and universally feared force on the modern battlefield, a powerful testament to its enduring design, its inherent adaptability, and the unwavering human ingenuity that powers its continuous improvement. The true ultimate measure of any weapon system lies not just in its impressive specifications, its innovative design, or its theoretical capabilities, but in its unwavering performance in the unforgiving crucible of combat. For the M1 Abrams, this baptism of fire, this ultimate proving ground, came primarily in the scorching desert sands of the Middle East, where it unequivocally proved its revolutionary capabilities, solidified its legendary status, and indelibly etched its absolute dominance into the annals of armored warfare.
Its operational history is not merely a record of engagements, but a profound testament to the unparalleled engineering prowess that created it and the profound courage and skill of the crews who operate it under the most extreme conditions. The first major combat deployment of the M1 Abrams was during Operation Desert Storm in 1991. Following Iraq's brazen invasion of Kuwait, a massive, unprecedented international coalition assembled to liberate the nation. The Abrams, primarily the M1A1 variant with its 120mm gun and depleted uranium armor, was the decisive spearhead of the ground offensive. Against the formidable, albeit largely Soviet-designed and often poorly maintained, Iraqi armored forces, which included thousands of T-72, T-62, and T-55 tanks, along with a vast array of anti-tank guided missile systems, the Abrams demonstrated an overwhelming, almost unbelievable superiority that bordered on the truly asymmetrical. The technological gap between the Abrams and its adversaries was not merely significant, it was immense, creating a profound, one-sided advantage. The Desert Storm campaign vividly showcased the Abrams' Big Three advantages, proving each design pillar was utterly justified. Overwhelming firepower. The 120mm smoothbore gun, coupled with advanced APFSDS depleted uranium rounds, specifically the M829A1 Silver Bullet, proved devastatingly capable of penetrating Iraqi tank armor at ranges often exceeding 2,500 meters, sometimes even more than 3,000 meters. Crucially, this often occurred before the older Iraqi tanks, lacking modern thermal sights and fire control, could even detect or effectively engage the Abrams. The hunter-killer capability and the vastly superior thermal sights of the Abrams crews allowed them to engage targets at night with devastating precision, effectively turning the darkness, which typically complicates combat, into an overwhelming, exclusive advantage. This precise, unseen destruction delivered a profound psychological blow to the Iraqi forces. They were being systematically destroyed by an enemy they often couldn't see, striking from beyond their effective range. Decisive mobility. Abrams units were able to conduct rapid, sweeping flanking maneuvers, traversing the vast open desert terrain with impressive speed, agility, and endurance, frequently outmaneuvering and encircling entire Iraqi forces. The turbine engine's immense power and responsive acceleration allowed for sustained high-speed operations, enabling coalition forces to execute the famous left hook maneuver, a daring, wide-enveloping movement with unprecedented swiftness and coordination, bypassing fixed defenses and cutting off retreat routes. Unmatched survivability. Perhaps the most striking and impactful aspect of the Abrams' performance was its near invulnerability to Iraqi anti-tank weapons and tank fire. While some Abrams were indeed damaged or immobilized by mines, tragically by friendly fire, or occasionally by mechanical issues, and in a few cases intentionally destroyed by their crews to prevent capture after immobilization, there were remarkably few instances of an Abrams being destroyed by direct enemy tank fire or anti-tank missiles with crew fatalities. The composite and depleted uranium armor simply shrugged off hits that would have catastrophically crippled or utterly destroyed lesser tanks.
This phenomenal level of protection fostered immense, tangible confidence among Abrams crews who knew deep in their bones that their vehicle offered an unparalleled level of protection. The visceral feeling of being inside that steel fortress, absorbing hits and continuing the fight, was a profound psychological boost, transforming potential fear into resolute determination and unwavering combat effectiveness. The battles of 73 Easting and Norfolk are emblematic of this dominance, where American armored units, spearheaded by the Abrams, annihilated entire Iraqi armored brigades with minimal or no losses in return. The infamous Highway of Death further underscored the destructive power of the combined air and ground offensive, with Abrams tanks playing a crucial role in preventing large formations of Iraqi forces from escaping. Operation Desert Storm firmly and unequivocally established the M1 Abrams as the undisputed, preeminent king of the battlefield, a technological and tactical marvel.
Years later, the Abrams once again found itself in the crucible of war during Operation Iraqi Freedom, hanging 20 This conflict, particularly in its later stages, presented a fundamentally different and far more complex challenge: protracted urban combat, the relentless threat of asymmetric attacks, and a tenacious insurgency. While the initial conventional phase again showcased the Abrams' overwhelming dominance against what remained of the Iraqi military, the subsequent insurgency brought new, brutal lessons and unforeseen challenges that demanded rapid adaptation. In the dense, complex labyrinth of urban environments, the Abrams faced threats it wasn't originally designed to primarily counter. Ambushes from close quarters, sophisticated improvised explosive devices (IEDs), rocket-propelled grenades (RPGs) fired from rooftops or hidden positions, and coordinated attacks by dismounted infantry. While the initial conventional phase again showcased the Abrams' overwhelming dominance against what remained of the Iraqi military, the subsequent insurgency brought new, brutal lessons and unforeseen challenges that demanded rapid adaptation. In the dense, complex labyrinth of urban environments, the Abrams faced threats it wasn't originally designed to primarily counter. Ambushes from close quarters, sophisticated improvised explosive devices (IEDs), rocket-propelled grenades (RPGs) fired from rooftops or hidden positions, and coordinated attacks by dismounted infantry. While the frontal armor remained largely impregnable even against these new threats, the less protected sides, rear and top of the tank, particularly against flanking attacks or top-down munitions, became points of concern. RPGs, though often unable to fully penetrate the main composite armor, could damage optics, disable tracks, or cripple secondary systems, disabling the tank without destroying it and leaving crews vulnerable to follow-on attacks. IEDs, particularly those employing explosively formed penetrators (EFPs), posed a significant and deadly threat to the belly and undercarriage of the tank, a previously less armored area. These new, evolving threats spurred further innovation and rapid, critical upgrades. The swift development and deployment of the Tank Urban Survival Kit, TUSK, was a direct and effective response to the harsh lessons learned in Iraq. TUSK added external layers of protection, including reactive armor tiles (ARA) to the side skirts, which detonate outwards upon impact, disrupting shaped charge jets before they could penetrate the main armor. It also incorporated specialized belly armor, often V-hull inserts, to mitigate the devastating threat of IEDs, slat armor to protect the vulnerable engine deck from RPGs, and a remote weapon station for the commander, allowing them to engage threats without exposing themselves to sniper fire or shrapnel. These crucial enhancements significantly improved the Abrams' resilience and survivability in urban combat, reducing vulnerabilities and dramatically enhancing crew safety. The remarkable adaptability of the Abrams platform, combined with the rapid pace of battlefield innovation and the unwavering commitment to protecting its crews, allowed it to evolve and continue to be a dominant force, even in the most challenging, unforeseen, and dynamically shifting environments. The profound human element within these conflicts, the experiences of the men and women inside these machines, cannot be overstated. For the Abrams crews, the tank was far more than just a tool. It was their home, their sanctuary, their ultimate weapon, and often their last line of defense. The immense pressure of combat, the grinding claustrophobia of the interior, the ceaseless roar of the engine, the bone-jarring concussions of battle, and the constant, terrifying threat of the unknown weighed heavily on every crew member. Yet the intensive training, the absolute trust in their magnificent machine, and the unbreakable, often unspoken, bond between crew members allowed them to push through unimaginable fear and fatigue. They profoundly understood the awesome destructive power they wielded and the immense responsibility that came with it. The palpable fear instilled in the enemy by the mere sight of an approaching Abrams or the sound of its grinding tracks was a powerful psychological weapon in itself, often breaking enemy morale before a shot was even fired. The Abrams, in the crucible of combat, is not
not merely a collection of steel, electronics, and destructive power. It is an embodiment of human will, unwavering courage, and unparalleled technological superiority, forged in the fires of war and proven time and again in the unforgiving deserts and urban landscapes. The M1 Abrams stands as a monumental, unparalleled achievement in military engineering, a machine that has not only rigorously adapted to the rapidly evolving landscape of warfare, but has actively shaped it. Its profound legacy extends far beyond the specific battlefields where it has proven its unparalleled mettle. It demonstrably influences global tank design, dictates modern tactical doctrines, and continues to symbolize American military might, unwavering resolve, and technological prowess. For over 4 decades, the Abrams has not merely been a participant in history, it has been a decisive force, consistently setting and continuously raising the gold standard in armored warfare. Its impact on global tank design is undeniable and far-reaching. Following the Abrams' unparalleled, near-flawless performance in Desert Storm, other nations around the world began to rapidly re-evaluate and, in many cases, fundamentally redesign their own main battle tank programs. The innovative concepts pioneered by the Abrams, particularly its revolutionary emphasis on survivability through advanced composite armor, the unprecedented power and multi-fuel capability of its turbine engine, and the surgical precision of its digital fire control system, became the new, indispensable benchmarks for all future tank development. Tanks developed in its wake, such as the German Leopard 2, which already had some similar, advanced features but further refined them, the British Challenger 2, and even later Russian and Chinese designs, all incorporated elements directly inspired by or explicitly responding to the Abrams' demonstrated capabilities. The global standard for main battle tanks fundamentally shifted, unequivocally demanding higher levels of active and passive protection, more sophisticated and integrated fire control, and greater strategic and tactical mobility. The era of simply adding more steel was definitively and irrevocably over. The era of smart, layered, multi-material protection, integrated digital systems, and networked combat had emphatically arrived, largely thanks to the groundbreaking innovation and proven success of the Abrams. The Abrams' continued, enduring relevance in a rapidly changing and increasingly complex threat landscape is a profound testament to its fundamental soundness, its inherent adaptability, and the unwavering commitment to continuous, iterative upgrades. While the geopolitical landscape has shifted dramatically from the Cold War's terrifying prospect of large-scale conventional warfare to more complex, often asymmetric conflicts involving non-state actors and insurgencies, the Abrams has proven remarkably versatile and adaptable. Its inherent versatility has allowed it to seamlessly transition from dominating vast open desert battles to effectively engaging in dense urban counterinsurgency operations, requiring entirely different tactics and protection schemes. The ongoing System Enhancement Package (SEP) upgrades, with their continuous focus on enhanced network integration, advanced sensor fusion, improved crew interfaces, and significantly improved survivability against improvised threats, ensure that the Abrams remains formidable. Its inherent ability to integrate with emerging technologies such as unmanned aerial vehicles, UAVs for reconnaissance and targeting, advanced active protection systems like Trophy, and sophisticated battle management systems seamlessly positions it for continued relevance in future networked warfare concepts. It's no longer just a tank, it's a crucial, highly mobile, and lethal node in a vast, interconnected fighting force, capable of receiving and disseminating real-time intelligence. Moreover, the M1 Abrams represents far more than just an incredibly powerful piece of military hardware. It embodies the very spirit of American innovation, the rigorous demands of reliability under extreme conditions, and the unwavering dedication of the countless personnel who meticulously design, painstakingly build, diligently maintain, and courageously operate it. The intricate science, the ingenious design, and the continuous evolution behind the Abrams are a profound microcosm of America's industrial might, its technological ingenuity, and its military capabilities. It is a machine that demands nothing less than perfection from its myriad components and absolute excellence from its crew, and in return, it offers unparalleled performance, decisive combat effectiveness, and critical crew protection. The distinctive roar of its turbine engine, the earth-shaking thud of its 120mm cannon, the impenetrable, almost defiant gleam of its composite armor, these are the undeniable hallmarks of a machine that inspires profound awe and chilling fear in equal measure. The profound story of the M1 Abrams is, at its deepest level, a powerful narrative of combined human and technological excellence. It is the story of visionary engineers pushing the very boundaries of material science, propulsion technology, and digital integration. Of meticulous designers painstakingly crafting a weapon system for optimal performance and maximum crew safety. And of countless brave men and women in uniform who have courageously taken this magnificent machine into harm's way, risking everything. For these soldiers, the tank is not merely a formidable tool, it is a steadfast companion, a vital protector, and a powerful symbol of their unwavering resolve and collective strength. The immense confidence it instills, the profound feeling of empowerment it provides, the fundamental knowledge that it is meticulously designed to bring them home safely, these deep emotional anchors are as crucial and impactful as any technical specification or combat statistic. The Abrams is not just a cold machine of war, it is a crucible where raw courage meets cutting-edge capability, forging an unstoppable force. As the world inevitably looks to the future, with new, unforeseen threats perpetually emerging and military technologies advancing at an exponential pace, the M1 Abrams continues its relentless evolution. Its dedicated designers and skilled operators remain profoundly committed to ensuring that it will retain its absolute dominance, adapting to new, complex challenges and seamlessly integrating new, advanced capabilities. The M1 Abrams is a living legend, an enduring testament to American ingenuity and engineering prowess, and a machine that will undoubtedly continue to set the gold standard in armored warfare for generations to come, standing as an enduring symbol of strength, innovation, and the relentless, unyielding pursuit of battlefield supremacy. Its incredible journey from a drawing board concept to a combat-proven, iconic weapon system is a compelling, multifaceted narrative of ambition, engineering brilliance, and the enduring human spirit that tirelessly drives innovation in the face of conflict. The deep, resonant rumble of its tracks surging across the terrain is not just the sound of a tank moving, it is the powerful, rhythmic heartbeat of modern warfare, a profound, ever-present reminder of the M1 Abrams' unwavering, impactful legacy.